everyone. Well, today we have gathered to begin this very nice article on differentiation of determinants. If you can recall, when I write a general determinant, say of order 2, and I fill it up with figures, with numbers, okay, then the value of this determinant comes out to be what? 2 into 1 minus 0 into 1, that is a number. Now, when I talk about differentiating a determinant, that means I am actually differentiating the value of that determinant. Right now, if I talk about the determinant of order 2 or order 3 or of order 4, whatever, filled up with numbers, that means each entry is a real number, then the determinant's value also is a real number, right? And when you differentiate a determinant, that means you are differentiating this number, which is going to eventually come out to be 0. So obviously, I am not interested in differentiating determinants which are filled up with real numbers, because each time I would be getting 0 as the answer. What instead we do is, under this article of differentiation of determinants, differentiation of determinants beginning with differentiation of determinant of order 2, I need 4 entries, 1 1th entry, 1 2th entry, 2 1th entry and 2 2th entry. To first of all understand the differentiation of determinant of order 2, I need 4 entries, which if I take differentiable functions, then what is the picture? So I am saying let f1x, f2x, f3x, or let me take g1x and g2x. So f1, f2, g1, g2 be 4 differentiable functions of x. Okay, these are 4 differentiable functions of x. This means what? That f dash x, or I should say f1 dash x, f2 dash x, g1 dash x, g2 dash x exist. Or I can write d by dx of f1, d by dx of f2, d by dx of g1, d by dx of g2, which we write like this, that exists full-fledgedly, nicely, because they are differentiable functions. Fine. I define delta determinant as the determinant of order 2 cross 2 in which each entry is a differentiable function. So I suppose keep f1x here, f2x here, g1x here and g2x here. Try to understand this very nicely. 1 1th entry in this determinant of order 2 cross 2 is a differentiable functions of x. 1 2th entry is another differentiable function of x. 2 1th entry is another differentiable function of x, and 2 2th entry is another differentiable function of x. In this case, when you evaluate this determinant, obviously the methodology is going to be exactly the same. It will be product of diagonals minus product of off diagonals. So it will be f1 into g2 minus f2 into g1. What can you see this is? This is pointwise product of these two functions, which is again a function. Pointwise product of these two functions, which is again a function. So this is one function, this is one function. Subtraction of two functions is again a function. So this completely is one single function of x, but this is equal to delta. That means actually delta is a function of x. So when all the entries are functions of x, this is denoted by delta x. We don't differentiate delta, we differentiate delta x, right? Because this is representing that delta is a function of x. Is it clear? Here entries are actually functions. What eventually is coming out as the value of this determinant is not a real number, but it is a function of x. Now try to understand this. If f1 and g2 individually are differentiable, f2 and g1 individually they are differentiable, You know that pointwise product of two differentiable functions is differentiable, so even this is differentiable and even this is a differentiable function. If these two are individually now differentiable functions, subtraction of two differentiable functions is again differentiable. So even this complete function, single function, is differentiable function of x, which eventually means that delta x is a differentiable function of x. Written in the form of determinant actually is a function which is coming out to be differentiable function of x, because each entry in that determinant is a differentiable function of x. So we have got, therefore, delta x is a differentiable function of x, which means d by dx of delta x, which is also denoted by delta dash x, exists. One thing is sure, that delta dash exists. But what is it and how do we compute it? Okay. Consider delta x. Now delta x is coming out to be f1g2 minus f2g1. Okay, I am just writing the resolved form. I am not writing this form. This we have resolved, we have got it this. So this is equal to f1x g2x minus f2 g1. Clear? I am saying d by dx of delta x exists. This will be equal to d by dx of f1x g2x minus f2x g1x. Differentiation of subtraction of two differentiable functions is subtraction of differentiation of those two individual functions. So differentiation of the difference is difference of the individual differentiations. So it will be d by dx of f1x g2x minus d by dx of f2x g1x. Clear? Differentiation of the product of two differentiable functions. Product rule, here also product rule, because individually these two functions are differentiable and these two functions are differentiable. So you have it to be equal to first function, this is equal to first function into differentiation of second plus second function into differentiation of first. Then you have here plus first function differentiation of second plus second function differentiation of first. Clear? You have got this as the value of delta dash x. Okay, let's just try to make a box over this and keep it as it is. Okay. Now what I am going to do is I am going to connect it to a certain rule, a certain methodology, which is going to make the computation of differentiation of determinant very, very easy to you. How do you actually get delta dash x without following this conventional procedure of obtaining the differentiation? Let's consider something. I will be considering two things, one corresponding to the row, another corresponding to the column. Please try to see this. I am saying consider the determinant of order 2 cross 2 only, that is what we are concerned right now. Here my first row is f1, f2, second row is g1, g2. What I will be doing is I will be considering the sum of two determinants of order 2 cross 2. Fine? So I will be taking one determinant of order 2 cross 2 and adding it up with another determinant of order 2 cross 2. Fine, no problem. Wherein the first determinant will be obtained by differentiating the first row here, keeping the second row as it is, and second determinant will be keeping the first row as it is, keeping the differentiation of the second row. So here in the first row I will have f1 dash x, f2 dash x, second row remains the same, and here opposite. So first row as it is, second row is obtained when you differentiate each entry in the second row. So it's like first row is replaced by the differentiated first row, and when that is done, second row is not disturbed. Plus, in another determinant, first row is kept as it is and second row's differentiated row is kept. So first row's differentiated row, second row as it is, first row as it is, second row's differentiated form is kept. Let's try to resolve this. If you resolve this, what do you get? Just resolve this. F1 dash G2 minus F2 dash G1 plus F1 G2 dash F1 G2 dash minus F2 G1 dash. So you have F1 dash G2 minus F2 dash G1. So here this is what you have. Here what did you have? This minus this. So here actually it is a minus and here also it's a minus. Okay, this you wrote and then minus this. So you have what? F1 dash G2 minus F2 dash G1 plus F1 G2 dash minus F2 G1 dash. Exact same thing. This is coming out to be your delta dash x. So one thing is very clear, that if I focus upon the rows of delta x, then by following this simple small rule, I can very easily obtain delta dash x. What is that rule? If delta x is differentiable, we could understand here it is differentiable because the 4 entries that it consists of, they are all differentiable functions. So clearly delta x is differentiable. What is its differentiation? To obtain its differentiation, what can you do? You can write this 2 cross 2 determinant as the sum of 2 determinants of the same order 2 cross 2. So this 2 cross 2 determinant will be written as the sum of 2 cross 2 determinants. How many sum of determinants you can write? As many as the order. Order is 2, so you can write this as sum of 2 determinants, and those 2 determinants are exactly of the same order 2 cross 2 as that of the main determinant. Wherein the first determinant is obtained by differentiating the first row and keeping the second row as it is, and in the second determinant you keep the first row as it is and differentiate the second row. That's what you do. If you perform this methodology, you obtain delta dash x. Is it clear? That is when you focus upon the row representation of delta. That means you focus upon this representation that delta x is row 1 and below it is row 2. So you are actually saying if delta x is considered as row 1 and then row 2, then delta dash x is what? It is the sum of 2 determinants, both of order 2 cross 2, in which in the first determinant row 1 is differentiated and row 2 is as it is, and in the second determinant row 1 is as it is and row 2 is differentiated. Is it clear? Now, another way is, if you don't do this, if you focus upon the column representation of delta x, not the row, then what is going to happen? So what you do, you consider again the sum of 2 cross 2 determinants. Now we are going to focus upon the column aspect. Is it clear? How? This is my original determinant given to me, f1x, f2x, g1x, g2x. Right now what did I do in the previous case? I considered the row aspect of it. I can alternatively write delta x as row 1, row 2. Now I will consider it in a separate format. How will I consider it in a separate format? Let me rub this. I'll show you. Okay, so alternate way of writing delta x. What is delta x actually? It is f1x, f2x, g1x, g2x. right? Now you can think of it as this is the first column and this is the second column. So you can write this as column 1, column 2, right? Either you can consider this as row 1, row 2 and write it in this format, or you can consider delta x as made up with 2 columns and write it like this. Now, if you are interested in understanding delta x as made up with 2 columns, column 1 and column 2, then in that case, what is the easy method to obtain delta dash x? Please try to see this. What you do, in the first determinant of order 2 cross 2, you differentiate the first column. Okay, differentiate the first column, keep the second column as it is. And in the second determinant, you keep the first column as it is and differentiate the second column. Just exact same thing like we did in the rows. In the row case, we first differentiated the first row and in that determinant kept the second row as it is. In the second determinant, I differentiated the second row and kept the first row as it is. And those were the 2 determinants that I added. Here I am doing the same thing with the columns. Now you try to evaluate this. This is f1 dash g2 minus f2 g1 dash plus f1 g2 dash minus f2 dash g1. Try to see this, f1 dash g2. So you have this f1 dash g2 minus f2 g1 dash minus f2 g1 dash plus f1 g2 dash minus g1 f2 dash. Exact same stuff that is written here. So this is actually equal to delta dash x. That is what is the next method to obtain delta dash. If you are sure that delta x is a differentiable function of x, then delta dash is nothing but the sum of 2 determinants of the exact same order 2 cross 2. Of the exact same order 2 cross 2, which are obtained how? The first determinant is obtained by differentiating the first column and keeping the second column as it is. And the second determinant is obtained when you keep the first column as it is and differentiate the second determinant. So if you are writing delta x as this, that means it is made up with columns, then delta dash x is actually, if delta is a determinant of order 2 cross 2, it's of order 2, then delta dash is equal to the sum of 2 determinants, each of order 2 cross 2, in which the first determinant is obtained when you differentiate the first column and keep the second column as it is, and the second determinant, keep the first column as it is and differentiate the second column. Is it clear? This is the drill. These are 2 drills actually. One is this and the other is this. Depending upon you are perceiving your determinant as made up with rows or made up with columns, both are going to give you the same representation of delta dash x. An exact same argument gets continued with determinant of order 3. And similarly, you can continue with determinant of order 4. Let me just tell you this. Now for determinant of order 3, how many entries do you need? 9 entries you need. 1 1th, 1 2th, 1 3th, 2 1th, 2 2th, 2 3th, 3 1th, 3 2th and 3 3th. So let me take F1, F2, F3, G1, G2, G3 and H1, H2, H3. Let these be 9 differentiable functions of x. Okay, I have my delta x as this determinant of order 3 cross 3. There is F1, there is F2, there is F3, G1, G2, G3, H1, H2, H3. When you evaluate this determinant, when you solve this with respect to any row, expanding along any row or any column, what you will be getting is a function only. It will be pointwise product of functions, sum of functions, subtraction of differentiable functions. Eventually that entire representation is going to represent a single differentiable function of x. When all these are differentiable, their any algebraic combination is also differentiable, which eventually means delta x is differentiable, which implies delta dash x, or what you write as d by dx of delta x, exists. And you don't need to prove now, you know that first way to understand and obtain delta dash is what? By considering delta as made up with rows. So there is a row 1, there is a row 2, there is a row 3. So because this is a determinant of order 3 cross 3, delta dash will be equal to sum of 3 determinants of the same order 3 cross 3. In the first determinant, what will you do? Differentiate the first row, kept the 2 rows as it is. Second, keep the first row as it is, differentiate the second row, third row as it is. Here, first row, second row as it is, differentiate the third row. So what you will be getting if I connect it with the example? Differentiate the first row. Right now I am considering this made up with 3 rows. Row 1, this is row 2, and this is row 3. I am considering it made up with 3 rows. So differentiate the first row, f1 dash, f2 dash, f3 dash. Rest as it is, g1, g2, g3, h1, h2, h3. Here keep the first as it is, differentiate the second, third as it is. Here first as it is, second as it is, differentiate the third. This is your delta dash. Or if you are considering it as made up with columns, then this would be what? You are going to have this as your first column, this as your second column, and this as your third column, right? This would be column 1, column 2, and column 3. So you will be considering this made up with column 1, column 2, and column 3. If that's the scenario, then first of all, your very delta dash, because delta is a determinant of order 3, delta dash is going to be the sum of 3 determinants, each of order 3 cross 3. So delta dash x will be 1, 2, 3, each of order 3 cross 3. First determinant will be obtained when you differentiate the first column, keeping the second and third column as it is. Here you keep the first and third column as it is and differentiate the second column. Here you keep the first and second column as it is and differentiate the third column. That means eventually it is turning out to be, you differentiate the first column, you get f1 dash, f2 dash, g1 dash and h1 dash, and keep the second column as it is, third column as it is. Plus next 3 cross 3 determinant, keep the first column as it is, differentiate the second column, third as it is. Clear? Here you have first as it is, second as it is, third as it is. Basically first and second as it is, third you have kept the differentiated one. That is how you can extend the argument for differentiation of determinant of order 4 also, 5 also, and so on. So you've completely understood the drill, the concept behind how to differentiate a determinant. Is it clear? Let's try to apply all this learning over a certain question which demands us to use the concept of differentiation of determinant. Concept is exactly the same. Depending upon the order of the determinant which you are wishing to differentiate, you actually write the differentiated determinant as the sum of those many determinants of that same order. And you know how those determinants are formed. Okay? Let's talk about this question. Question says that let f, g, h be differentiable functions of x. Here they have formed a determinant. F, g, h is differentiable. X, you know, is an identity function which is always differentiable, and pointwise product of differentiable function is differentiable. So even xf, xg and xh are differentiable, and their differentiations are again differentiable, you know that. So even the second row is consisting of differentiable functions. Now x square is differentiable. F, G, H are already given to be differentiable, so their pointwise product is differentiable. In fact, you can find out their second derivative is also a function of x, which is a differentiable function of x. So even third row is consisting of each function as differentiable function of x. Right? So this is the determinant which is having all its entries as differentiable function of x. So even delta is differentiable. Delta dash is given to be this. Here it is unknown. N is unknown. It is saying if delta is this and delta dash is this, then what do you think is n equal to? For what value of n will delta dash when delta is this is equal to this? So let's try to resolve delta a bit, and when we will be reaching with the the most simplified form of delta, then I will differentiate delta. Okay, right now derivative is not known, double derivative is not known. So let's try to resolve delta. First row is as it is, f, g, h. Second row you have x, f dash. Now please try to see x, f dash, derivative of two functions. First function derivative of second plus second function derivative of first. D by dx of x is 1, so f into 1 is f. Next entry is x, g dash. First function differentiation of second plus second function differentiation of first. Again d by dx of x is 1, no relevance to write anything. Then you have xh dash as the third entry. It is first function differentiation of second plus second function differentiation of first. Let's write it down, the resolved form. So let me just write it in a spacious form. This is f, g, h. So you have xf dash plus f, xg dash plus g, xh dash plus h. Right? Similarly, we will be trying to resolve the third column as well. You have x square f double dash. First, let's try to evaluate single dash, then we will derivate it again. This is again first function differentiation of second plus second function differentiation of first. D by dx of x square is 2x. Let's differentiate it once again. What would this be? First function differentiation of second plus second function differentiation of first. Here also same thing. First function differentiation of second, d by dx of x is 1 plus second function differentiation of first. So you have 2f dash x, 2f dash x. This is x square f double dash plus 4f dash x plus 2f. Exactly similarly, in place of f you will get g. So x square g double dash will be x square g double dash plus 4g dash x plus 2g. Just replace f by g, rest everything is going to be the same. And similarly x square h double dash will be x square h double dash plus 4h dash x. 4h dash, this is not f dash of x, this is actually f dash into x. G dash into x, h dash into x, because x independently is one function given over here, plus 2h. Is it clear? Let's write this down. This is x square f double dash plus 4f dash x, or let me write this as 4xf dash, that's better, plus 2f. Here you have x square g double dash plus 4xg dash plus 2g. Here you have x square h double dash plus 4xh dash plus 2h. So I have actually tried to resolve delta. Fine. Now see, this is pretty easy. Now if you can see, here also there is F, here is F, here is G, here is G, here is H, here is H. So very clear row operation would be rho 2 goes to rho 2 minus rho 1. And one more thing, here it is 2F, here it is F, 2G, G, 2H, H. So I can say rho 3 goes to rho 3 minus twice of rho 1. In this case, delta turns out to be equal to first remains as it is, first row. Second is modified to second minus first. Xf dash plus F minus F leaves you with Xf dash. Xg dash plus G minus G leaves you with Xg dash. Xh dash plus H minus H leaves you with Xh dash. Rho 3 goes to rho 3 minus twice of rho 1. So this minus 2F gives you just X square F double dash plus 4X F dash. Similarly, this minus 2G, 2G cancels out, you're left with X square G double dash plus 4X G dash. And this complete thing minus 2H. So 2H goes out, X square H double dash plus 4X H dash. Now pretty much of it is resolved. Try to see this. This is 4xf dash, xf dash, 4xg dash, xg dash, 4xh dash, xh dash. So clearly I have the next operation coming up to just resolve it more. Rho 3 goes to rho 3 minus 4 times rho 2. Let's see. Rho 1 is as it is. Rho 2 is as it is. Rho 3 goes to rho 3 minus 4 times rho 2. 4 times rho 2 means, rho 3 minus 4 times rho 2 means x square f double dash plus 4xf dash minus 4xf dash, you are left with x square f double dash. Here similarly you are left with x square g double dash after performing the operation, and here also x square h double dash. Now you can see in my delta dash, there is no x here, only x is present in the third row. So what I am going to do, I am going to make my second row also free from x and keep every x in the third row only, so that I get closer and closer to delta dash representation. First row already is free from x, let me make second row also free from x. Now I can take out x common, x can obviously come out common, we are aware about the properties of determinant. You are left with f dash, g dash, h dash, and here it is x square f double dash, x square g double dash, x square h double dash. And I can now multiply this with the third row. So you will be having this x vanishes and this comes out to be x cube, again x cube, again x cube. So somehow this is now very, very, very close to my delta dash, isn't it? Right? First row, second row, free from x, all the x's are in the third row. Now let's perform delta dash. Now, delta is a determinant of order 3 cross 3. So delta dash can be written as sum of 3 determinants, each of order 3 cross 3, wherein the first will be obtained by differentiating the first row, keeping the next two intact. Here differentiate the second row, keep first and third intact. Differentiate the third row, retain the first and two as it is. So differentiate the first row, this is f dash, g dash, h dash, this is my delta. Rest 2 as it is. Rest 2 as it is. Here differentiate the second row. Second row will become f double dash, g double dash, h double dash. First row as it is. Third row as it is. In the third determinant, you keep the first and second row as it is and differentiate the third row. So x cube f double dash dash, x cube g double dash dash, x cube h double dash whole dash. That's what we learnt in differentiation. Now see that in this determinant, two rows are exactly the same. The moment you have two identical rows, the value of that determinant is 0. So this entire determinant is 0. Here you can see I can take out x cube common from this third row. The moment I take out x cube common, I have second row and third row identical. So the value of this determinant is 0. 0 into x cube is 0. So even this completely is equal to 0. You are just left with this f, g, h, f dash, g dash, h dash, x cube f dash, double dash, x cube, g dash, double dash, x cube, h dash, double dash. Is it clear? Now try to focus upon something. This is now your delta dash. 0 plus anything is that thing. So this is your delta dash. And what delta dash is given to you? This. Exact same is this and this, only if I replace n by 3. Isn't it? It's fgh. Yes, here also fgh. Here it is f dash g dash h dash, the second row, f dash g dash h dash. Here it is x cube f dash double dash, x cube g dash double dash, x cube h dash whole double dash. Here also, what is it? Here actually this is double dash and this is dash, yeah. This is double dash and this is dash, that's what we've written over here. So even the third row is exactly the same, only if I replace n by 3. So for what value of n is delta dash equal to this? We know this is my delta dash for n equal to 3, and that is what is the answer. That's how you apply the differentiation of determinant concept to reach through the solution of questions like these. In the next lecture, we'll be talking about integration of determinant, okay? And then I'll see you then. That's it from my side. Thank you.